Okay, let's dive into this. Welcome to this explainer where we're embarking on a global expedition into the world's most massive, most powerful, and honestly, probably most mysterious body of water. Today we're decoding the Pacific Ocean. We'll be using historical records and hard data to map out exactly what makes this ocean not just a geographic wonder, but literally the lifeblood of our planet. Every single concept we look at today builds a picture of an ecosystem that's, well, it's as terrifying as it is beautiful. So get ready, because the sheer scale of what we're about to explore is absolutely going to blow your mind.
Part 1. The Ocean of Extremes. To truly grasp the staggering scale of the Pacific, we have to start super wide, like zoom all the way out into space wide. When you view the Earth from just the right angle, you don't even see a blue marble dotted with green continents. You just see a solid, unbroken expanse of deep blue. Check this out. On one side, we have the total landmass of Earth. That's every single continent, every island, every speck of dry land combined, totaling roughly 150 million square kilometers. On the other side, the Pacific Ocean, spanning an unfathomable 170 million square kilometers. Let that sink in for a second. You could effortlessly drown every single continent on Earth inside the Pacific, and you'd still have a massive 20 million square kilometers of water left over. It's almost too large for the human brain to even process.
And it's not just about surface area, it's about volume. 710 million. That is the jaw-dropping amount of water the Pacific holds, in cubic kilometers. We're talking more than half of all the free water on our entire planet. And within this unimaginable volume of water, you get some wildly extreme variations in temperature. Up near the poles, the water drops to a freezing minus 1.4 degrees Celsius. But if you travel down to the equator, you're going to find balmy, bath-like waters reaching up to 30 degrees Celsius. It's just a world of absolute thermal contrasts. To put this scale into perspective even more, let's look at its absolute widest point. Stretching all the way from the coasts of Indonesia across the globe to Colombia in South America, the Pacific spans approximately 16,000 kilometers. Now, if you were to take our moon, our actual celestial neighbor in space, and line it up across that expanse, you could fit 5 whole moons, end to end, across the ocean's surface. I mean, no way, right? It literally makes our closest neighbor in space look tiny by comparison. Moving on to part 2, Voyagers of the Pacific. Despite this terrifying size, our ancestors have actually been conquering this massive expanse since prehistoric times. Just think about this. Around 45,000 years ago, ancient humans achieved the impossible, crossing parts of this ocean from Indonesia to step foot in Australia. Jump forward to 3000 BC, and we see the Austronesian expansion starting from Taiwan. These navigators used nothing but the stars, the currents, and the wind to settle the Philippines, Indonesia, and even as far as Madagascar. They eventually established these vast maritime trade routes spanning all the way from Mozambique to Japan. And then, much later in 1521, we get the first global circumnavigation attempt by Ferdinand Magellan. Which brings us to this really deep historical irony. Mar Pacifico, or the Peaceful Sea. That's the name given to the ocean by that Portuguese explorer Ferdinand Magellan in 1521. But here's the thing. He didn't name it that because the ocean is inherently calm. He named it out of sheer exhausted relief. After surviving the absolutely brutal, storm-ravaged waters at the southern tip of South America, a passage we now call the Strait of Magellan, his fleet finally entered these new waters. The calm, favorable weather they encountered must have felt like a miracle, earning the ocean a gentle name that, quite frankly, hides its truly violent potential.
All right, part 3. Into the Abyss.
Now, what's really interesting here is that we're leaving the calm surface and heading straight down, completely shattering our terrestrial bias. We always think of Mount Everest as the ultimate extreme of our planet, right? Standing a proud 8 kilometers tall. But the Challenger Deep, located in the Mariana Trench, plunges more than 11 kilometers into the Earth's crust. If you were to literally rip Mount Everest out of the Himalayas and drop it straight into the Mariana Trench, its highest peak would still be completely submerged under roughly 3 kilometers of pitch black water. The vertical scale here is just staggering. And the Challenger Deep isn't just a fluke. The Pacific claims the top 5 deepest points on the entire planet. We've got the Mariana Trench, the Tonga Trench at over 10,800 meters, followed by the Kuril-Kamchatka, the Philippine, and the Kermadec Trenches. Every single one of these chasms plunges well beyond the 10,000-meter mark. It's this wild subterranean landscape of deep, hidden scars carved across the ocean floor. Going down there, yeah, it's honestly harder than going into space. The crushing pressure is unimaginable. Yet we absolutely have to highlight the immense bravery of the few deep-sea pioneers who have actually done it. In 1960, Jacques Piccard and Don Walsh became the very first humans to make the solitary, incredibly dangerous descent to the Challenger Deep. And it was so difficult that it took over 50 years before anyone did it again solo, when the acclaimed filmmaker James Cameron made his historic dive in 2012.
Section 4, The Ring of Fire.
So,
The Pacific isn't just deep and dark, it's explosive. We're going to completely contrast Magellan's idea of a peaceful sea with the violent, fiery reality of the ocean's tectonic edges. Get this. A staggering 75% of all active volcanoes on Earth are located right here in the Pacific Ring of Fire, leaving just 25% for the entire rest of the world. We're talking about a 40,000-kilometer perimeter holding over 450 active volcanoes. It's just a continuous, terrifying chain of geological fury.
And all that volcanism brings something else with it. 90%. That is the percentage of all global earthquakes that happen precisely within this region. Why? Because the Pacific plate is constantly, violently crashing into and sliding beneath the surrounding continental plates. The Earth here is constantly trembling, fracturing, and resetting. It is literally the epicenter of natural destruction on Earth.
Beyond the Earth shaking, the water itself breeds extreme weather, presenting this massive dual threat of monster storms generated by the ocean's shifting surface temperatures. Over in the eastern Pacific, these cyclonic beasts are called hurricanes, battering the coasts of the Americas. In the northwestern Pacific, they're called typhoons, unleashing destruction on Japan and East Asia. Add in the global climate chaos, driven by the ocean's El Niño and La Niña temperature cycles, and you basically have a giant engine for extreme worldwide weather events.
Part 5. Islands and Marine Life.
Now, for all its destructive power, the Pacific is also an unparalleled cradle of life, home to an incredible archipelago of over 25,000 islands scattered across its waters. To make sense of them, researchers map them out into 3 massive cultural zones. Up north, we have Micronesia, home to the Mariana and Marshall Islands. Down to the south is Melanesia, which notably includes New Guinea. And fun fact, that's actually the world's second largest island right after Greenland. And finally, we have the vast Polynesia, forming this massive geographic triangle connecting Hawaii, New Zealand, and Easter Island. The cultural richness here is honestly as deep as the ocean itself.
And this brilliantly illustrates how vital this ocean is to our daily human survival. An astounding 70% of the world's marine fish catch comes straight out of the Pacific Ocean. Only 30% is supplied by the rest of the world's oceans combined. Without the sheer bounty of the Pacific, global food security would pretty much collapse overnight. The life beneath the waves is just extraordinary, hosting the undisputed marine giants of our world. We're talking about the blue whale, the absolute largest animal to ever exist on Earth. Deep below that, you have the mysterious giant squid, living alongside countless species of sharks and tuna. And along the coastlines, you find the rainforests of the sea, these massive, intricate coral ecosystems, with Australia's breathtaking Great Barrier Reef being the most famous and biodiverse of them all. Our final section, Part 6, A Fragile Giant.
Sadly, this massive, powerful ocean is currently facing unprecedented human-made crises that threaten to unravel its entire ecosystem. We really need to understand the chemistry of ocean acidification here. As greenhouse gases rise in our atmosphere, the ocean acts like a giant sponge, absorbing that excess carbon dioxide. When that CO2 dissolves in salt water, it forms carbonic acid, which aggressively lowers the water's pH. We are essentially, day by day, turning the ocean into an acidic trap.
Let's walk through this deadly step-by-step process. Step 1. Human activity increases greenhouse gases. Step 2. The ocean absorbs it, forming that carbonic acid. Step 3. This acidic water literally eats away at the calcium carbonate shells of marine life. Snails, clams, and, most tragically, coral reefs completely lose their ability to maintain their structures. This chemical chain reaction is the direct, undeniable cause of the tragic mass bleaching and death we're witnessing in places like the Great Barrier Reef right now. And as if climate change wasn't enough to worry about, we have this surprising geological fact to consider. Because of the intense tectonic activity we discussed earlier, the Pacific Ocean is actually shrinking. It's losing about 2.5 centimeters, or 1 inch, every single year. So while the Atlantic is growing, the Pacific is slowly closing. This natural shrinkage is happening at the exact same time the ocean is battling compounding human threats, melting polar ice caps, dangerous sea level rise, and the horrifying plastic pollution that has formed the Great Pacific Garbage Patch. Which leaves us with a final, pretty provocative question. What happens to human civilization if we let this foundation collapse? The Pacific Ocean regulates our global climate, it feeds billions of people, and it drives the very geological heartbeat of our planet. It is not just a body of water, guys, it is the cornerstone of life on Earth. Protecting this irreplaceable wonder isn't just about saving nature, it's about saving ourselves. I hope this explainer has given you a deeper, much clearer understanding of the Pacific's profound impact on our world. Thank you so much for learning with me today.